Hello, today we're going to look at multiplying indices. So to this question here, 2 cubed multiplied by 2 squared, I could calculate that and the answer would be 32. However, I would actually like my answer in index form, which what I mean by that is 2 raised to a power. And to do this, let's think of what 2 cubed means. So 2 cubed means 2 multiplied by 2 multiplied by 2. So that's what 2 cubed means. And 2 squared means multiplied by 2 multiplied by 2. So that part there is the 2 cubed and that part there is the 2 squared, and they're multiplying together. So if you see, that there is the same as 2 to the power 5. Now I don't know whether you've noticed this, but actually what is the link between the powers here and that 5? Well, if you add them together, the answer is 5. And actually you can see that because 2 cubed means 2 multiplied by itself 3 times, 2 squared is 2 times 2. So yeah, that's right that it should be 2 to the 5. And I can see why when I add these indices I get 5. Let's do another one. Here, 3 to the power of 4 multiplied by 3 squared. Well, let's think about that adding thing. Well, if it works, that adding idea, this would be 3 to the power of 4, add 2, which is 3 to the power of 6. Let's see whether it really works by doing the proper maths behind that. Well, 3 to the power of 4, that's what 3 to the power of 4 means. And 3 squared, that would be that. And therefore, if I look at that all now, that would be 3 to the power of 1, 2, 3, 4, 5, 6. And actually, yeah, if I add the indices together, the 4 and the 2, I do get 6. So it looks like this method's working. And it does. And you can see why it does. And that's the shortcut. But the reason it's important to learn this is because often we forget what the rules are. And this is an indice rule which says when these, the base number, because these are called the base numbers, when the base numbers are the same, and they are multiplying, you can add the indices. So when the base numbers are the same, they've got to be the same, both 3s, both 2s, you can add the indices to get the final answer in an index form. Okay, so looking at the shortcut, what do you think the answer to the first one would be? 5 to the power of 6. Well done. Now press pause and I want you to have a go at the next two. Can you get them right without my help? Have a go. When you've written the answers down in your book, press play. So, hoping you've now written those answers down, this next one would be 6 to the power of 11. And I can do that because my bases are the same. Are my bases the same? Yes, they're both 7. So this could be 7 to the power of... I've got a negative there. So it's negative 5. Add 11. Think of that number line if you're getting stuck. And that should be 6. Did you get those answers? If you did, really, really well done, because that's really impressive. If you didn't, go back, look. It's really important to understand what went wrong. It's not about just going, oh, I've got a different answer, but why did you get that different answer? That's where the big mathematical thinking comes about. Right, so make sure you do those corrections and understand, and moving on. So here, what's different? Now if I look, my bases aren't all the same. That is the same base as that one, and this 3 to the power of 4 is the same base as this 3 to the power of 3. So I can rewrite this answer to this question to start with, and using what's called the commutative law. And what the commutative law is, that if you do 3 multiplied by 2, you know that's 6. Well, if you alter the order when you multiply, 2 multiplied by 3, you still get 6. So when you have a line of values that are multiplying, the order can be changed. So I'm going to change my order and write this like this. So you notice what I've done here is I've grouped together the values that have the same base. So when I've got some numbers written in index form and they have the same base, I've grouped them together. So here I now have all of my values that have a base 2, and here I have all of my that have a base 3. So now I can use my rule as before, because here this would be 2 and that would be to the power of 8, because I've added 3 and 5. Now I can't link the 2 and the 3 together because they're different bases. So I've got to leave my 2 to the power 8 as 2 to the power 8, and now I'm going to write this as 3 to the power of 7, because I've got a 4 and a 3, and I add those 2 to get my 7. And that there is my final answer. I can't simplify it anymore, and the reason I can't simplify it anymore is because the 3 and the 2 are different bases. So just recapping on that, first thing I did was I noticed I had different bases. Then using the commutative law with multiplication, I grouped together those that have the same base. So here's the base of a 2 and here's the base of 3. And then I've simplified that part there as 2 to the power 8, and this part here is 3 to the power 7, and I cannot simplify anymore. That's it. I could if I wanted a final answer, but I want my answer in index form, so that's it. So let's do one more. Now, what am I going to do to start with? Do you know? What's the first thing? Have a think, have a go. So first of all, copy the question out, and then pause, and I want you to write down what you think the answer is. I don't want you to press play until you've redone what you think the next line is. Okay, what I'm hoping you've done is you've realised you've got 2 different bases. You have bases of 4 and you have bases of 7, and you've rewritten that using the commutative law, and you've grouped them like that. Brilliant. So now what do you do next? So think about the rule we've learnt about when the base number is the same and they're multiplying. What can you do with the indices? Press pause, write down what you think the next line will be. Okay, I'm hoping you've written 4 to the power of 9 multiplied by 7 to the power of, I've got a negative again, so I've got to use that number line. So -2 add 4 would be 2. Now, if you're not quite sure about that, you need to go and rewatch the video. because it's really important to understand what we're doing, and then you need to do some practice.